Welcome back to Machine Learning Guide. I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. Where your other machine learning resources provide the trees, I provide the forest. Visual is the best primary learning modality, but audio is a great supplement during exercise, commute, and chores. Consider MLG your syllabus with highly curated resources for each episode's details at ocdevel.com/MLG. I'm also starting a new podcast which could use your support. It's called Lefner's Life Hacks and teaches productivity-focused tips and tricks, some which could prove beneficial in your machine learning education journey. Find that at ocdevel.com/LLH. You're listening to Machine Learning Applied. It's been a while. I'm very sorry, everyone. I got very busy for a minute there, but I'm getting back on the horse. The next 3 episodes in this series are going to be on visualization, and in particular on exploratory data analysis, or EDA. Before we get into the visualization stuff, this episode is going to cover Jupyter Notebooks, Jupyter. And I'm sure most, if not all of you, are already pretty well versed in Jupyter Notebooks. They're pretty difficult to avoid when immersing yourself in machine learning. Lots of blog posts, GitHub repositories, tutorials, etc. are done by way of Jupyter Notebooks, but I haven't covered them officially, so let's get that out of the way here. The project Jupyter was previously called IPython Notebooks. They renamed it to Jupyter, Jupyter, because now they're supporting multiple languages, and they have a much broader scope of what they're trying to accomplish. The name itself sort of encapsulates some of the languages that it supports. For example, JU for Julia. Julia is a programming language for data science. PY for Python. I don't know what TER is. I imagine the R at the end is for the R programming language. But that just shows that the Jupyter project is now compatible with multiple languages. We'll be focusing on Python because that's our focus in this podcast series. And the idea of a Jupyter Notebook is that you write a code file, like a Python file, but that you can publish it to the web or to GitHub or in other locations where people might be viewing your Python file, and that Python file tells a story. It's more than just a script that you run on the command line. A Jupyter Notebook takes that Python file and turns it from a script that you run into a piece-by-piece visual storytelling experience. So let me explain that. If you were to write a Python file where you're ingesting data from a spreadsheet, like a CSV file, or from a database like Postgres, you might use pandas.readcsv or pandas.readsql. Now you might write some Python to do some exploratory data analysis of your own. You might render some charts and graphs using matplotlib. And when you run your script to perform some simple EDA, and we'll talk about exploratory data analysis, EDA, in the next episode. But when you run your script to perform some of that EDA, matplotlib might pop open a window for you to look at some charts and graphs. Okay, you'll close that window, you'll delete that code or comment it out, and you'll perform some data munging. Maybe you'll replace some null values or use robust scalar or standard scalar to scale your data. Then you'll pipe your data into a machine learning model and run the model. And when you run the script, you'll see the output of your model being run, whether it's in Keras or TensorFlow or scikit-learn. Maybe the output of that script might be the loss value of the loss function over time, and then eventually a mean squared error or an accuracy metric if you're doing a classification task. That'll be all printed on the command line, on the terminal. You'll see these values. And things might look good to you, so you take the results of your model and you pipe it into some charts and graphs that you're going to show some business decision makers. Well, you render those images as PNG files. Those PNG files have the charts and graphs, bar charts, pie charts, whatever, and then you email those things to the business users. So I went pretty fast with that process, but you get the idea that you're writing Python code in a Python script, and there's multiple phases to this process. And at various phases in the process, there might be visualizations, but those are done by popping open a window for you to look at, and then you close the window and you delete the code and you replace that with some other code. And what you have in the end is a Python script minus all the visualizations, minus the sort of story that took you through the process of pulling in the data, exploring the data visually, running the model a few times until you're satisfied with your metrics, and then generating a report by way of visualizations that you're going to send to a business user. That whole story from beginning to end, well, that's a pretty important story to capture all of it. It's unfortunate that writing a script like that, beginning to end, sort of loses a lot of information along the way. Maybe in the future, somebody wants to pick up your file and sort of see the start to finish. Or let's say you wanted to write this whole thing as a tutorial on a blog post, or you wanted to present the visualizations and outputs of the various parts of your script to a web page so people can see just how you went about the whole process, beginning to end. That's where Jupyter comes in handy. Jupyter Notebooks. A Jupyter Notebook is basically a Python file that runs in the browser as a sort of dedicated web page. What you'll do is you'll install Jupyter, pip install Jupyter, or conda install Jupyter if you're using Anaconda. And then in the terminal, you'll type Jupyter Notebook, and that'll open up a Chrome tab. And in that Chrome tab will be sort of your dashboard where you can create a new Jupyter Notebook. And the way Jupyter Notebooks are structured are as cells, individual cells. In each cell, you can write some code and then execute it. You can write Python code, R code, Julia, Scala, etc. So you write some Python code. Let's say that the first cell you write is a bunch of import statements. You import matplotlib, you import scikit-learn, keras, TensorFlow, blah, 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 blah. And then you hit Control-Enter, it'll execute that cell. And if there's any output from that cell, it will print the output directly under the cell. Now, when you have a bunch of import statements, there's no output. So you hit Control-Enter, it shows the cell as having been run, and then you move on to create a new cell. In that new cell, maybe you'll ingest a data source. You'll read a CSV file, pandas.read_CSV, or you'll read data from a database, pandas.read_SQL. Now, you may want to do some basic exploratory data analysis, which we'll talk about in the next episode. Maybe you want to see if there are any null values in your data frame, or you want to see the mean, min, max, median, etc. You might type df.info, dataframe.info, or df.describe, parentheses, and hit Control-Enter. So now this is your second cell chunk of code. When you hit Control-Enter, it executes that code, and it prints the result of that execution below the cell. So you'll actually see the output of running dataframe.info, parentheses. It'll actually print the results underneath the cell. Now, let's say you create a new cell. Okay, so you have your imports, you ingested your data into a data frame, and it printed some information about that data under that second cell. That's still visible while you continue to work on your third cell. Maybe in the third cell, you build up a neural network using keras, and you pipe in your data frame to train your model, and you hit Control-Enter, and the output of training a keras model is line by line the loss as it improves over time, including some speed metrics, how long it took to run over a batch of data, and then by the end, either you've reached the maximum epochs or you have some early stopping callback or such. It'll print your main metric, like mean squared error or accuracy. So all that stuff will be printed under your third cell when you hit Control-Enter. So you step back and you look at your Jupyter Notebook, and what you see is each chunk of code that's relevant to a specific step in your pipeline, in your process. First, you imported your stuff. Then you ingested your data. Then you built and ran a model. And under each chunk of code, under each cell, is the output of running that cell. Now, this has a lot of value because rather than writing multiple scripts that you have to run independently and discard the output, you get to keep the output after running each phase of your pipeline. And if you wanted to publish this Jupyter Notebook online, you wanted to put it on a blog post, a tutorial, or even just commit it to GitHub, GitHub actually has a Jupyter Notebook rendering engine in the same way that they have syntax highlighting for Python and JavaScript and all that. If you were to open a Jupyter Notebook in GitHub, it'll actually render the Jupyter Notebook properly in your browser. And you'll get to see not only the code in the cells of that Jupyter Notebook, but the last output of each cell's run in that Jupyter Notebook. So if you were to write a Jupyter Notebook file cell by cell where you ingest the data, you pipe it through a machine learning model, and you output the results of the machine learning model. And all that output is captured under each cell, and you commit that to GitHub. Somebody else were to come along to your GitHub repository, click one of your Jupyter Notebooks, they'll get to see the stepwise process, including the output from each cell's execution. So you can sort of build up a story of the process of your data pipeline in one of these Jupyter Notebooks. And it's not just limited to code. There are a few other things that you can do. One is that these cells don't have to be code cells. They can be markdown cells. So rather than just having a code block in Python, a whole bunch of lines with hashtags indicating that this is a code block, and you're talking your way through this process, you can actually have markdown, which allows you to have a much more elegant presentation of each of the phases of your file. So if you wanted to separate the data ingestion from the EDA, from the model building, you might have a markdown cell above each of those cells describing what you're doing in each of those phases, and you're allowed to use markdown formatting such as double hashtags for an H2 and bolded list items, and even inline images and videos if necessary. Another very important piece of Jupyter Notebooks is that it allows you to inline render charts and graphs using charting libraries like matplotlib. We'll talk about matplotlib in one of the next 2 episodes in this 3-part series. But in short, matplotlib is the core charting library for charting your data, which may be data that you imported from an Excel spreadsheet into your Pandas data frame. You can use matplotlib to plot the data in your data frame. You can do line charts, bar charts, histograms, correlation matrices. We'll talk about all this stuff in a bit. One command you might use is df.corr, C-O-R-R, parentheses, which will plot a correlation matrix. And Jupyter Notebooks allow you to render that plot, render that chart inline directly as the output of executing that cell. So captured in the output of your Jupyter Notebook are these charts and graphs. So you're telling the story of developing your machine learning model from beginning with the data to ending with running your machine learning model, including in the exploratory data analysis phase, rendering charts and graphs that allow you to visualize your data. Are there outliers? How do different features interact with each other? How is one feature distributed in a histogram, etc.? So that's Jupyter Notebook. Jupyter Notebook is like writing a Python file, a Python script, but rather than just executing it beginning to end, as you would with a Python script, you execute it in chunks in a Jupyter Notebook, and each chunk or cell will capture the output right under the cell so that you can build up this story that took you from beginning to end in this file. And that includes markdown cells, which allows you to describe what's coming in subsequent cells. It includes inline matplotlib charts, which allows you to visually perform exploratory data analysis. And then you can publish your results to a blog post or to GitHub or a tutorial or what have you. And one final nicety of Jupyter Notebooks is that you can execute these cells independent of each other. They don't have to be sequential. So let's say you do your imports up here, you execute that cell. Okay, now all of your imports are imported. And then you do your data ingestion. Maybe you're reading SQL from a database into your data frame. And let's say that data is really heavy. It takes a very long time to pull down. So you execute that cell, it takes 5-10 minutes, and now that cell is executed. Well, as you continue to write cells down below, let's say you're building up your model and piping the data into your model to train it. Well, you had a bug, something went wrong with the model, so you delete the model code, you delete that cell, but your cell with the data is still already run, which allows you to recreate a new cell to try again with your model and just execute that one cell. That way you can sort of build up this flow piecemeal, one at a time, without having to execute it beginning to end every time you want to run your file. Now, I should mention that Jupyter Notebooks are primarily used for storytelling. I keep using that word, telling a story piece by piece through the development of your model from data to execution, all that stuff. Jupyter Notebooks are primarily used for storytelling. So they're primarily used for publishing so somebody else can look at it. I find that most machine learning developers or data analysts, when they're doing their work just for them, they'll be using PyCharm or Vim or Emacs or whatever IDE or text editor and running these Python scripts in the traditional sense on their computer. It's just easier that way. And these IDEs, like PyCharm in particular, I'm a huge fan of PyCharm, have tons of tooling built into them where you can get signatures of functions, you can drill into functions with control-click, you can set debugger breakpoints and run the Python debugger on a file. All these things that really make your personal development workflow work for you. That's what I find. A lot of machine learning developers will do their own thing in a traditional Python script in PyCharm. But then once they want to build up their story and publish their results for other eyes to look at, they'll create a Jupyter Notebook and then commit that to Git or publish it to a blog. So that's Jupyter Notebook. Next episode, we'll unpack this idea of exploratory data analysis and start introducing some of these charts, like correlation matrices and histograms.